Okay, kiddos, now we are moving on to 11.3. We're going to talk about areas of polygons. All right, so last time we talked about circles, now polygons we've studied before. So now let's first talk about how to find the area of rhombuses and kites. So this one's pretty straightforward. Okay, so to find the area of a rhombus and a kite, okay, so with diagonals D1 and D2. So remember what a diagonal means, right? Diagonal means goes from one corner to the other one. So from one corner to the other one, that's diagonal 1, right? And then from this corner to this corner is called diagonal 2. So we just measure those, and the area formula is just you're going to take D1 and you're going to multiply it times D2 and you're going to just divide by 2. That's it. And so it doesn't matter what we have, whether it's something like this, that's still going to be D1, and something like that's going to be D2. So find the area of each of these. So this, of course, is a rhombus because it has all four sides that are the same length. Okay, so go ahead and see if you can find out the area of this. All right, so we said the area is D1 times D2 over 2, right? So that means the area is equal to 8 times 6 divided by 2. 8 times 6 is 48 divided by 2 gives us 24, right? So, of course, we could have just put this into our calculator just like that, but going the mathematical way, we get right to 24. Okay, and of course, we're going to say that that is meters squared because we're talking about meters, and because we're dealing with area, we need to have squared. Okay, so keeping that in mind, see if you can get this number 2 on your own. All right, so on this one, we said the area is D1 times D2 over 2. So that means the area is equal to the first one. We're not going to get tripped up by being 2, right? It's 2 plus 2. So 2 plus 2 gives us 4 times 3 plus 5, right, gives us 8 over 2. So it's 32 over 2, which gives us half of 32 is 16 centimeters squared, right? 16 centimeters squared. All right, so keeping that in mind, let's just move on from there to our next part. Okay, so that's it on those. All we have to do is do that. So now let's talk about regular polygons, okay? So what if we said something like this polygon right here inside of this circle? What if we wanted to find the area of that? Okay, so that's not a regular shape that we've been talking about. But if it's a regular polygon, we're going to talk about how we can do it today. So what does regular mean? Okay, regular means both equilateral, which means what? Equilateral means equal sides, right? Equal sides. And then equiangular means equal angles, right? So if we're dealing with a regular polygon like this, where it says equal sides, we can mark that by having, right, a tick mark on each one, right? That shows that all these sides are the same, right? And then if we say that they are equiangular, right, we can say they're equiangulars by having the same one single arc on each one, right? So if we're going to say that this is a regular polygon and we want to find the area that's inside here, these are the steps that we need to do. Okay, so this is what we have to recognize. Okay, so first off, let's identify the center of this regular polygon. So we know the center is, if we have a circumscribed circle, this is a circumscribed circle. What do you think that means? Circumscribed means all the corners are touching. Okay, all corners touch. Okay, they all touch the inside of that circle. As we see right over here, they're right on top of there. So when we do that, the center of the circle is also the center of this polygon, right? So we're going to say that center of that one is point P. Okay, so that's the center. Okay, now let's talk about the radius. Radius is similar to the radius of a circle. The radius is from the segment is a segment from the center to a vertex. Okay, from a center to a from a center to a vertex, or we can say from the center to a vertex, and the vertex is a corner, right? So we actually have two radiuses on this, and the first one would be T to N, right? PN. What's the other one? That's right, PM, right? PM right here is also a radius. We said from the center to a corner. Okay, now this is a new term right over here, apothem, right? It may be pronounced differently in your other classes, but it doesn't matter. It's the same thing. The apothem is similar to a radius. Okay, radius goes from the center to the vertex. The apothem goes, it's a segment or distance from the center to a side of a polygon that's inscribed. So if we see right over here, this blue line right here just goes to the side. So that goes to the side. That's called the apothem. So from the center to any side is that. Okay, so we're going to keep that in mind. And then the last one we're going to talk about is the central angle. Okay, we know the central angle is when we have two radiuses going. So we go for N, M, P to N. So we said the vertices are the corners, right? So it's going from two consecutive corners, which means next to each other, right? So M and N are both consecutive, so MPN. So angle MPN is our central angle. All right, so keeping that in mind, let's get right into some usages of that. Okay, so in this, it says WXYZ is a square inscribed in this circle P. That's what that means, circle P. We see a circle with P. Okay, good. Inscribed, meaning that they're all four corners touching. Okay, so pause the video, see if you can identify all these. All right, center. Center is point P. Okay, radius. Radius goes from P to the corner, right? So PY or PX. PY or PX, right? Apothem. We said the apothem goes from the center to a side, so center to the side. So we're going to say that's PQ, right? And then the central angle. What's our central angle? It goes from the center. It goes from two vertices, so XPY, XPY. Angle XPY. All right, so that's the basics of it. And so the main thing that we're going to be concentrating on today are the apothem and the radius. Remember, radius goes from the corner to the circle itself, because that makes sense, to the circle. Apothem just goes to the side of that polygon. Okay, so keeping that in mind, see what you remember about this. Hasn't been too long. What did we say about the central angle? Measure each central angle on this. All right, well, hopefully you tried. We said it goes from two consecutive corners through the center, right? So that is a central angle, right? And this is also a central angle, and that's a central angle, right? So the measure of each one is 360 divided by the number of sides, right? 1, 2, 3 sides equals 120 degrees. So 120 degrees for each central angle. Okay? Keeping that in mind, what do you think about this one? Similar thing, right? We say go from here to here. So how many sides do we have? 1, 2, 3, 4, 5, 6 sides, right? So we know we'd have 1, 2, 3, 4, 5, 6 central angles. They'd all be the same thing. How much would they each be? They'd be 360 divided by 6, so 60 degrees each, right? Okay, so keeping that in mind, see if you can get this last one. This is a little higher level, but you got this. A regular polygon with 8 sides. What we said is 360 divided by the number of sides, so that's going to be equal to 45 degrees. Okay, so that's all we got to keep in mind. All right, so keep that in mind as we move on to our second page, but the main thing we want to focus on going forward is the apothem and the radius. Those are the key things, the apothem being going from the center to a side and the radius from the center to the vertex. All right, so keeping that in mind, let's make sure that we have our calculator pulled up handy, because we're going to need our decimals calculator, and especially we're using trig today, so make sure it's in the degree mode. Okay, make sure it's in degree mode when we're working. All right, so let's go and get this guy out of the way, and let's get right into some practice. All right, so now if we're trying to find the area of a regular polygon, remember what we said regular means. Here's the formula. Okay, so we're going to take a couple different approaches today, but this is the technical way that they want you to know. Okay, so the area of a regular polygon is A, okay, that being the area. Okay, area is equal to 1/2 of the apothem times the perimeter. Okay, so we're going to use these abbreviations over here. Okay, apothem, we're going to use lowercase a for the apothem. Okay, the capital A is going to be area. Okay, and then capital P is going to be perimeter. And you said, what do we know about perimeter? Perimeter is all around, right? And the difference between that and the area is all inside, right? That's the difference between area and perimeter. Excuse me. So, what did we say we need to remember? The main thing we need to think of is the radius goes from where to where? The radius goes from the center to the circle, right? And then the apothem goes from the center to the side of the polygon, right? That's the difference between radius and apothem. Okay, so keeping that in mind, let's get into some practice. Okay, so this is going to make your brain hurt a little bit, but you got this. All right, so let's just stay focused and know that we got this. All right, so O is the center of this regular hexagon below. Okay, so given that it's regular, that tells us that we can use our formula right over here for the area of a regular polygon, because we're trying to find the perimeter though, but we can use this to find that. So let's go and use this. It says find the perimeter. Okay, so on this problem, that's what we're trying to do, is find the perimeter. Round to the nearest tenth. Okay, so we know that that means a decimal with just one place, right? One decimal place is what that means. All right, so let's go ahead and set it up. So the first step, okay, I'm going to go through the procedures. The first step is we want to find the central angle. Okay, so let's do that. How many sides do we have? 1, 2, 3, 4, 5, 6 sides, right? So we're going to say 360 divided by 6 equals 60 degrees. Okay, so that's our first step, is to find the central angle. Okay, that's step number 1. Okay, now step number 2. We're going to bisect the angle that we got from number 1. Okay, remember what bisect means, right? Bisect means divide by 2. So we're going to say 60 divided by 2, which gives us 30 degrees. Okay, so let's think about that. We said, let's draw in that central angle first, right? So we said the central angle goes from one corner through the center to the other one, right? So let's draw that in with a highlight in that central angle. Okay, so we said that we want to bisect it though, right? So bisect means go right down, and it's going to make a 90-degree angle, right? So here's the key though. If the whole thing is 60, right? The whole thing is 60, I bisect it to make a triangle, okay? Because if I can use this triangle, then I can use that to find my area. So when I bisect, I have to think, what is that? Well, if it's half of 60, that's 30 degrees. So that's the crucial thing, is that we need to recognize that that's 30 degrees right there. Okay, so once we bisect it, now we're getting into the higher level stuff. We're going to use trig to find the side. To find the side. Okay, because here's what we're thinking. Okay, if we can figure out how much this is, right? Then I can multiply this times 2 to find this side, right? Then I can take that, multiply it times 6 sides, and that will give me my perimeter, right? So that's how we're thinking, is we need to find this side, so then I can multiply it times 2, then I can multiply it times all my sides to find my perimeter. Okay, so let's use trig to find that. So keeping that in mind, remember when we're using trig, we're going to think of so ka toa, right? So ka toa. So the first thing we need to do is we need to label our sides. So we're going to label O, A, H, and A, right? Remember? Okay, so let's think about this. We're talking about this triangle right over here. Okay, so if we're talking about that triangle right over there, and we're looking from this perspective, remember what we're talking about, right? This over here, opposite, going this way, right, would give us our opposite side, right? Across from the right angle, right? We know if this comes straight down, that's a right angle. That's going to be our hypotenuse, right? And this is our adjacent. Okay. Now, if we think about this, this adjacent That's also the apothem or apothem, right? That's the apothem. Okay, just something to keep in mind, right? So that adjacent side is always going to be the apothem. All right, so now that we have those labeled, let's use our trig. Okay, so this is higher level. You got this. Higher level, but you got this. All right, so let's use trig to find the side. So what do we know? What sides are we using? We're using, we need to find this one right here, right? So that's like our x right there. That's what we're trying to find. So that, and we know h. So O and H. O and H is sine, right? So that means the sine of our angle measurement, right? Sine of 30 degrees is equal to the ratio of something over something, right? We know that sine is opposite over hypotenuse, right? So the opposite is what we're trying to find. That's x, right? Over the hypotenuse, which is 6. Okay? So now, if you remember, we just cross multiply, right? Put that over 1. 1 times x gives us x equals, and remember, sine of 30 times 6 is actually 6 times the sine of 30, right? 6 goes in front, so 6 times sine of 30. Okay, so now here's the critical thing. We had to remember to make sure that we are put it into degree mode. Okay, so if we don't have it in degree mode, we're going to get the wrong answer. So we're going to type that in, 6 sine 30, right? 6 sine 30, that's what we're going to type in. Okay, so if we do that, we're going to get x is equal to 3. Okay, so now we're not done. All right, so let's keep that in mind. That tells us that this side, this half of this side is 3, right? So our fourth step is we're going to multiply number 3 times 2 to get the side, a full side, right? So that means 3 times 2 is equal to 6, and that's our side, right? 6 is one side. Hey, now we're almost there. Hey, the perimeter is equal to 6, right? Which we said was the length of one side, times the number of sides, right? Actually, let me do this, right? Instead of saying 6, right? Let's just say whatever we get from number 4, right? So number 4 times the number of sides. So that's number 4 was 6, right? Times the number of sides, which also was 6, equals 36. So 36 units is our perimeter. Okay, so I know that's kind of tricky, but I know you can follow the math. So we just have to go step by step. So first thing we always want to do is we need to find that central angle. Once we found that central angle, we said, okay, let's split it, and then we can make a right triangle. If I know a right triangle, I can use trig, knowing this measurement, to find this side. Then if I know that side, I can double it, right? Multiply times 2 to get this side. Then if I have that side, my last step, I'll multiply that side times the number of sides, which gives me the perimeter. All right, so keeping that in mind, let's move on to our next one. Let's try to see if we can move this in a little faster now that we're getting even smarter. Mainly move that guy out of the way. All right, so let's look over here. It says O is the center of this dodecagon, right? We may have forgotten what that is, dodecagon, but let's count it. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, right? So that means the 12 sides on dodecagon. Find the perimeter. Okay, so same thing. We need to follow those same steps and go to the nearest tenth on this one. Okay, so let's do it. Okay, so on this we said first thing we need to do is find the central angle. So the central angle is, we said 360 divided by number of sides. So 12 sides gives us 30 degrees, right? Number 2, we said we're going to bisect it, right? So we said we're going to take 30 divided by 2. That's going to give us 15 degrees. Okay, so let's go ahead and draw in our central angle, right? We said the central angle is going to be from one corner to the next. So let's kind of draw that in to kind of visualize it for us. Okay, then we said we are going to split it so that we, let me draw that better. We said we're going to split it so that we have a right triangle, right? So I'm just going to kind of highlight this triangle in here so we can kind of see it, right? So this is the triangle that we're trying to work with. We're trying to find the area of this. You're trying to work with that triangle so that we can find this length, right? And then once we find that, this side, we know, okay, we can double it to find that, then multiply it times 12 to find our perimeter, right? Okay, so that's how we troubleshoot. All right, so how much is this angle? We said the whole thing was 30, right? So that means that angle, that smaller angle, was 15, right? So let's think about that. We know this is A, right? This is going to be opposite. That's hypotenuse. So now, what sides are we working with? We need to find the opposite, and we have the adjacent. So opposite and adjacent is TOA, right? So that's tangent. Okay, so we said for step number 3, we're going to say the tangent of our reference angle, right, which is 15 degrees, is equal to the ratio of the opposite over the adjacent. So the opposite is what we're trying to find, right, which is x. And if you notice, we're trying to do it, keep x on the top, because when we multiply times 1, we automatically have x, right? So whatever function we want to use, we want to keep the x on top. So we'll keep that in mind for later on. All right, so x is opposite over the adjacent. Adjacent, we said, is always going to be this 13. Okay, now let's cross multiply, right? So that gives us x equals 13 tangent 15. Okay, so if we put that in a calculator, that's going to be approximately, now here's one thing. 10th place is 1 decimal, right? But here's the key. We need to make sure that we get to 5 decimals over here because we do not want to round too quickly. Okay, we don't want to round what we call a rounding error. So let's do this. Instead of 3.4, I'm going to write down 5. I'm going to say 8,334. So I'm going to use 5 digits. Okay, and that's how we don't get what we call a rounding error. Okay, so we're going to say that x is that. Okay, so that's that one. So now we said number 4 was to multiply, take number 3 times 2, right? So that's going to be equal to, if we put that in our calculator, 2 of those, 2 times 3.48334 would give me 6.96668, right? Okay, now step number 5, so that gives me the side, right? But we don't want the side, we want the whole perimeter. So the perimeter is 12 sides times 6.96668, right? Makes sense. So that means the perimeter is approximately, now we can round to our nearest tenth, which is 1 decimal place. So we're going to say that is approximately 83.6. Okay? So hopefully now with our practice, we took a complicated problem and we just applied our skills that we've been practicing all year, putting it all together and got that. All right, so keeping that in mind, let's keep it moving. So on these first 2, we were trying to find the perimeter. Okay, perimeter on both of these. So now we are moving on, okay, from perimeter to area. Okay, so now we're stepping it up a little bit differently, but we got this. All right, let's look. This is, O is the center of this regular polygon. A regular telling us that what we know, they're equal angular and equilateral. Find the area. Okay, now this is a little bit different. Find the area, round to the nearest tenth. Okay, so still, first step is to find our central angle. So we're going to say how many sides? 1, 2, 3, 4, 5, 6, 7, 8. And we also know that because the octagon, right, tells us 8 sides. So we're going to say 360 divided by 8, which is going to give us 45 degrees. Okay. Step number 2, though, we said we want to bisect it, right? Because think about it, right? We want to have, if we're going to say this is our central angle, right? We want to make a triangle just like that, right? Okay, so we're going to bisect it. So we're going to say 45 divided by 2, which is equal to 22.5 degrees, right? So that means that is 22.5 degrees. Okay, so keeping that in mind, let's keep it moving. If we want to find the area, though, let's do this. Okay, if we want to find the area of the whole thing, here's what we're going to do. We're going to find the area of this triangle, right? And then we're going to multiply it times 2 to find this. Then we're going to multiply that times the number of sides to get the whole thing. Okay, so that's how we're going to use our trig to find the answer for the whole thing. All right, so to find the area of a triangle, okay, area of a triangle is equal to 1/2 times base times height, right? 1/2 times base times height. Okay, so let's keep that in mind. So if we're going to use our trig, what sides are we working with, right? What do we need to find? We need to find both. Wow, we need to find both this, right, which is the base, and this, which is the height. We don't have any of those. The only thing we have is the hypotenuse, right? So let's go ahead and label the sides, right? From this, though, this is what we would call the opposite, right? And that would be the apothem, right, or the adjacent side. So let's work with this first, right? So if I want to find that, I would say that's label that as x first, right? So if I'm working with the opposite side and the hypotenuse, opposite and hypotenuse is sine, right? Opposite and hypotenuse. So we're going to say the sine of 22.5 is equal to the ratio of opposite, which is x, over the hypotenuse, which is 9, right? So we remember so, right? So that means x equals 9 sine 22.5, right? So if we put that in our calculator, that's going to give us x is approximately, remember we said we're going to put 5 decimal places, right? So we don't make an error. All right, so now that I know what this is, right? Now I need to figure out what this side is, right? So let's now think about how I could use this. I could use that number, but that's gross. That's a nice number. So A and H, right? A and H is c, right? So that's cosine. So step number, now we're going to say cosine of 22.5 is equal to the ratio of adjacent over hypotenuse, right? So adjacent, now this is my new x, right? I'm going to change that to a red color because that's my new x I'm trying to find, right? And we're going to say our hypotenuse is 9, right? A over H, AH. Our new x is that over 9, right? So since I have the x on top, that makes it easier. I cross multiply, right, over 1. So that means x is equal to 9 cosine 22.5, right? And if we put that in our calculator, that's going to be approximately 8.31492. Okay, so keeping that in mind, let's talk about our, so that is the same thing as our apothem, right? Okay, so let's keep that in mind. That's our apothem. This is keeping us with the same thing as finding the area of that each of those triangles. So we said to find the area of a regular polygon, the area is 1/2 times the apothem times the perimeter. Perimeter is the whole thing. Okay, so we could do it like that, or we can think of it a different way, right? Remember we said it doesn't matter how we do it as long as we get the same right answer, right? So we could find the area of this triangle, right? And then multiply it times 2 to find that, and then multiply that times 8 to get the whole thing, right? So if the area of a triangle is 1/2 times base times height, we're going to say the area of the triangle, right, is equal to 1/2 parentheses. The base is this first one that we calculated, right? And that was at 3.44415, right? Times the height, right, which we said was our apothem, right? Or apothem, however you want to say it, 8.31492, right? So that's the area of that small triangle. Okay? Now, that gives me, so the area of the small triangle is going to be equal to 14.31892, right? Now, I said I'm going to take that, right, and then multiply it times 2 right, to find this. Then I'm going to multiply that times 8 sides, right? So if I did that, that would give me approximately 229.1. All right, so I know that looks quite complicated, and it is. It's the most complicated thing we've ever done, right? But we know what we're going to do is first we're going to find that central angle. Knowing that if I can find this triangle, then I can find the area of that, multiply it times 2, multiply it times 8 to get the whole thing. All right, so found that central angle, then I found this bisected angle, then I used trig along with the hypotenuse to find this side. Okay, once I had that side, then I used trig with this hypotenuse and that side to find that side. Once I use that, I found this is my height. That's my base. 1/2 times the base times the height gives me area of that. Then I multiply that times 2 to give me this triangle. And then I multiply it times 8 to give me the whole area. All right, so let's do our last problem right over here. Okay, it says O is the center of the regular nonagon over here. Find the area. Okay, so we said the first step, we're going to find our central angle, right? So the central angle is equal to how many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Because the nonagon means 9 sides. So 360 divided by 9. You may be getting better with your math. You got 40 degrees. Second step is to bisect it. Right, so we're going to say that it's 40 divided by 2, which gives us 20 degrees, right? So now let's go ahead and draw our triangle in there so we get an idea. Okay, so we know that's our central angle, right? So this is the triangle that we're talking about right over here, right? So if we do that, let's go ahead and put in our new bisected angle is 20, right? So if we're trying to find this right over here first, right now, we have the height, right? We just need the base. We don't need this hypotenuse at all to find the area because we said the area of a triangle, right? Area of a triangle is equal to 1/2 base times height. So we don't care about this. So what are we working with? This is the A side, right? And this X is going to be the opposite side, right? So what do we work with? TOA, right? TOA works with opposite over adjacent. Okay, so let's set it up. We're going to say the tangent of 20 degrees is equal to the ratio of x over 6, right? So if we put that over 1, that means x equals 6 tangent 20. Okay, so if we do that, that means x is approximately, remember we said we're going to do 5 decimal points, x is approximately 2.18382, right? So now that we have the base and our height, right, let's just put it into our formula. So the area of that triangle, right, we said was 1/2 times the base times the height. So the area of the triangle is equal to 1/2 times the base of 2.18382, right, times the height of 6, right? So that gives us approximately 6.55146, right? Okay, so now that we've done that, we know that that's the area of just this little triangle right over here, right? So once we have that, we need to multiply that times 2 times 9, right? So we're going to say the area of the whole thing is equal to 6.55146, right? Times 2 triangles times 9, right? So that's going to be approximately, rounded to the nearest tenth, 117.9. Okay, so that's what we need to know is just setting it up into the correct format. We got to think about what type of trig we're going to use, but we're always going to find our central angle first. Then we're going to bisect it and then figure out from our SOHCAHTOA what we're going to do. All right, so you can do this. Let me know if you have any questions. Let's make it happen.